Hi, so welcome to this live session. My name is Dhananjay, and this is the second session on Python, Fun with Python. So now in first session, we had covered about the different aspects of Python programming. We had got started with Python programming and we had done the setup. And then we went ahead and then we created few programs, and then eventually we understood the concept of how the programming works, what is programming in general. And we went ahead and created a swapping program, and then we ended with the area of figures, geometric figures program, where we created programs to find areas of circle, area of rectangle, square, different type of figures. So in today's session, we will be continuing our discussion by then, and we will go into a little bit advanced topic. In case you missed the first session, then you can go and watch the recording live, recording on our YouTube channel, which is Robot Genius channel. You can go and watch the recording. And to continue to get updates and these kind of live sessions, you can subscribe to our channel. And if you like this session, then do like the session, right? So, okay, so let's get started now. So hopefully you have got the setup with yourself, and I'll actually start my share. And so today, in Python, that's what we are going to do. We'll understand what exactly is loop. So and we'll actually start with blocks, then we will go on, and then we will work with if and else statements. And then we will go ahead and then we will look at what exactly is, what is loops. And then we will go and we'll make our final project of this session, which is number guessing game, right? So let's then get started. Hopefully you have your setup ready and you have understanding about how Python programming works. So now let's look into the concept. So so let me just, as a refresher, let me just explain you some concepts about Python programming. So this is VS Code, and we did cover the setup instructions in the last class. So you can you can actually install Python from python.org, and you can also download Visual Studio Code, and then you can get started with writing the programs, right? So now so today's session 2, let's do some basics of Python.py. So .py is the extension which you use for Python programming. Okay, so so as you know, the programming works from top to bottom. So I can actually provide an expression. This is an expression. This is also known as statement. The statement is actually one unit of code which will do something, and expressions are something which can be part of the statement. One statement can consist of multiple expressions. So these expressions are evaluated, and then eventually the statement is executed. Like, for example, this statement is just an assignment statement, right? So it's one unit of code, the smallest unit of logical code, which will be executed by the computer, by the Python interpreter. So this is an assignment statement, right? And then let me give you an example about the expression. So let's say I have y. Now, if I say x plus 10, x plus 10 is actually an expression, right? I can also say, right, divided by, let's say, x plus 2. So again, this becomes another expression. Now, this program consists of two expressions. So this statement, the statement at line number 2 consists of two expressions, and these expressions will be evaluated, and then this statement will be executed, and eventually the calculation of this expression will be stored in Y. And these are the things which we covered. And as we covered that, right, the execution of the program will happen from top to bottom, and the assignment will always happen from right to left. The assignment will always happen from right to left. Okay. So if, let's say, if I say X is equal to Y, then this means that value of Y will be assigned to X. It will not be other way around. Okay. So these are the things which we which we have understood from the last program. Now, as the Python executes the code, it will execute the code from top to bottom. And now if we want our code to become more intelligent, then we can include control flow statements, right? So what are the control flow statements? So control flow statements are statements which which when encountered will take different path of execution, right? So we call it like control flow statements. And this is basically, you basically want to do certain things on certain conditions. So let's say, for example, if it's raining, if I say it's raining, and if I say this is true, then I should actually instruct the users, instruct some person to carry, or basically instruct myself to carry an umbrella, right? So this is basically, so if I have such kind of program, and then I want to make my program more intelligent by including control flow statements. So this is how something we can do that. So this is basically one of the control flow statements. Like that, there are multiple control flow statements. So we have like loops as well. Again, they are control flow. So we will move to loops in a bit. Right. So now let's moving on. Right. So now the next thing is, when we talk about control flow statements, we have to talk about block of code. Okay. So block of code are like certain pieces of code which you want to be executed together, which should be executed together. Okay. So like, for example, I am actually including, I want to do that if a number is greater than 5, then I want to say something, right? Something. And this can be a number, it can be maybe a time or something, where maybe you want to greet somebody. So I want to say if X is greater than 5, then I will say friend, X is a big number, right? That's what I want to do. And then what I want to do, since X is a big number, I want to reduce 1 from X, right? So I have reduced 1 from X, and this is how it will work. So 1 will be reduced from X, and this value would be assigned to X, right? So this is what I want to do. And then I will simply want to print it, right? I want to print the value of X. So I'll say X is equal to X. This is what I want to do. Now let's run this. So now the way to run it is you go to, and then we use the Python command to run this, and we're running from within the terminal of VS Code. So basics, right? So, and you see that indeed we are getting this value X, which is coming from this line, right? And it's actually not printing this this number, right? Which means this expression actually has changed this value, right? So what we will do, we'll just get rid of this, and we will run this program again. Now, for in this case, we are sure that x is actually greater than 5 because the value of x is 10, and this is what we are doing the comparison, right? So this is what we are doing the comparison. And we are using this if statement. So if statement will actually check the condition which is there along with the if statement. And if this condition is true, then only this block will be executed. This block of code will be executed only if this statement is true. If this statement is not true, or this expression is not true, then this block of code will not be executed. Now these two lines are actually part of one block of code, and that is what we call it the block, because they're together, right? So this is one block of code. And in Python, we actually indicate the block by using this tab of spaces. It can be single space, it can be a tab, but that's how. So starting of the block need to have a space. So it can be like tab, or it can be just single space even. But if you're using single space, then that's how you have to use. You have to use single space for all the statements inside the block, and that's how. So x is a big number. Now you see that it is going inside this, and it is able to execute the statement, and it is able to recalculate the value of x, assign it to x, and then that's what the value of x is getting printed, right? So I will just make a small x. So now you see that these two statements are actually part of this block, right? These statements are part of this, we call it if block, right? And so now this statement is actually is outside the block. Now, if we want this statement also to be part of this block, we again have to put the tab. Now, if you're familiar with other programming languages like C, C++, Python behaves in a little bit different way. So in Python, we use these kind of spaces. Spaces have meaning in Python, but whereas in C, C++, Java, JavaScript, these are different languages which have taken from C, but their spaces have absolutely no value. So in those languages, like in language like C, C++, Java, the spaces have no value, and to indicate the block, you actually use curly brackets. Okay, in Python, curly brackets are used to denote a different kind of data type. So we don't use curly brackets in this. So we will come to that, this data type as well. Right. So, but for the block, we don't use any curly braces. We use the spaces to indicate that these statements are part of this block. And then we have this colon, which tells Python that, okay, a block of code is coming. So as soon as Python encounters there is a colon, it will actually expect a block of code. It will expect that the next statement should have some space. Like, for example, if I remove this, then you see that it's giving an error, right? And it is giving me this error that no, there is a problem. String appended to last value. So there is some problem with that. So, right. So this is actually the block of code which is there. And now this is part of this block, right? And if we run this, you see that it is printing this, indeed is printing this statement as well, because it is going inside this block, and then it is actually executing all the statements. Now, let's say we reduce this value. Let's say we make it 4. In this case, it will not go inside this, and actually we will not get any output, right? We are not getting any output. So what we can do is we can actually include basically a block of statement if the condition is not true, right? So we will actually say print x is a small number, and in this case we want to increment, the value of x. Now it is going to print this value, x is a small number, but it will increment the value, but we will not get the value of x. So now let's say we want the statement to be common. So we want the statement to be common, and then we put it, right here. Sorry, not really that statement. We want this particular statement, right? We want this particular statement. And we put it here. Now, can you spot the issue in this program? Can you see what I have made wrong? So let's run this program, and we're interested in printing the value of x after whether it is incremented or decremented, right? If it's a small number, we want to increment it. If it's a big number, we want to decrement it. So you see that it is printing this x is equal to 5, which is fine. It works perfectly fine for this case. But let's say the value is bigger than 5, then what happens? Then you see that it is not printing this x value. Now, you may be thinking that why it is not printing this value. And actually, I think you must be able to see that this statement is actually part of this block. So what we have to do to make this outside the block, so what we can do is, can we put a space? Can we put a blank line? Will this make it out of the block? So let's run it and see. Actually not. This statement still is not part of the block. So to make this out of this block, and this statement should not be part of else block, we will have to remove the space which is coming in front of this. So now in this case, this becomes a statement which is not part of this either if block or else block, and will be executed every time this program is executed, right? So we run this, and you can see that we have this output x is equal to 5, and this will also work for lower value of 5 as well, right? So this is the meaning of the block. So the block, basically, how many blocks we have in this program? We have actually 2 blocks. This is block number 1, and this is block number 2. We call it if block, and we call it else block, right? So this is basically, we have 2 blocks. Okay, so we have used actually if and else without getting much into this. So let's now look at if and else, right? What exactly is if and else? Now, Python is a lot, makes use of lot English-like language, so it becomes more intuitive, more easy to understand. In fact, if and else is there in almost all the programming languages, because that lets you, follow different path for the code. So now exactly what is if? If, like in our general, in common basically the way we use if, right? For example, if I'm hungry, I'm going to eat food, right? So that could be one condition. And then you can combine multiple conditions. You can say, if I'm hungry and if food is good, then only I'm going to eat food, right? So that could be another way to combine it, right? So this is basically if, and that's where the keyword is actually, first of all, we are combining, when we're combining 2 conditions, we are putting and. So like, for example, we have if, and then we will have condition 1 and condition 2. So if both the condition is true, then only this statement will be executed. Okay, so we will come to this 2 conditions later. First, let's look at the first condition. It's just one condition. So we have if statement, and we are providing it one condition, right? So we're just providing it one condition. So now the way if will work is, if this condition is true, then only whatever statements are there, this is going to execute that. Okay, it is going to execute that. If this is false, then the program control will not go inside this, if it is false. Okay, so this is what we have actually used in this program, and you can see that we have this if statement. So that's why this control is actually going inside this, right? So now you can also visualize this code by using a very special tool, which is actually called Python Tutor, right? So you can go to this tool, using this tool, you will be able to visualize the execution. So we'll click on edit this code, and then what we will do is we will paste this code. So we pasted our code, and then we can say visualize execution. So when we are doing visualize execution, now we will be able to execute these statements step by step, line by line, by clicking on next. What exactly is happening? So you see that as soon as I clicked on next, it from line 1, it executed a line number 1 where it assigned a value of x to 3, and then it skipped line 2 because line 2 is blank and line 3 is the comment, right? It's a comment which will be ignored by Python, and then it comes to line number 4, and then now when I click on next, it's going to evaluate this condition, whether this condition, which is x is greater than 5, is true or false. So now it will evaluate, and actually it finds that x is actually less than 5. So which means this condition is false. And in that case, it is going to come to the else part. So when it comes to this else part, in this case, now it is right here. And when we, so it has jumped to the else block, and it's right here at the line number 8. And when we click that, it will execute this line. And you see that it's printing x is a small number, and then it is it executed statement 9 and assigned the value of 4 to x, and then it has come to line number 11. And when we execute this line also, it prints the value x is equal to 4. So in this way, you can visualize the execution. You can visualize the execution step by step. Now, code can be more complicated, and this gives you a very handy tool to actually go and go step by step and visualize. And maybe if you're not understanding, if there is an issue, then you can use this tool to even debug your code. Okay, so now you may be having question, what exactly is debugging? We will look into that a bit later. What exactly is debugging, right? So now, this is this is how if works. This is how if works. Now, and if so, now, so if we have to provide this condition, right? So this condition is there. In this case, this condition which is there is an expression, and it is using these operators. We call them operators, right? So in in Python we have. In Python, we have different type of operators. So first of all, we have arithmetic operator, right? What are the arithmetic operators? Plus, minus, multiplication, then division. These are the regular operators. Little bit more advanced are. This is the floor division operator. This is the exponential operator, which is also called like power operator, and this is my modulus operator. Now, what do these operators mean? Let's go to Python shell and let's see for what exactly are these operators. So let me launch the Python shell, and so we are right here, and you can see that let's assign value of x is equal to 20 and value of y is equal to 10. Let's use these operators. So plus, minus, division, and multiplication, you are aware. So what is floor division, right? So what is floor division? So floor division is an extension of division. So if I say x divided by y, so it is going to divide this value, and it will give me the value 2, right? And I can actually floor this answer. So it's going to give me the integer value 2. Now, you may be thinking that 2.0 and 2 are same. So how exactly floor division works? So floor division will, the difference will be evident if the value which you're getting is fractional value. Like for example, let's say if I divide 3 by 2, right? So if I divide 3 by 2, I'm going to get the response as 1.5. But I want to floor this value. And I am just interested in the integer part of this value, right? I'm just interested in the integer part of this value. So I'm just going to floor this, right? So floor is like coming from, so if I have a value like, 1.5, so there'll be a value below it, which will be 1.0. And then there'll be a value above it, which will be 2.0. And these are actually the integer values. These are the integer values, which is 2 and 1. So if we are saying we want to floor it, which means we are coming here to this base. And if you're saying that, no, we want to seal it, which is sealing. There is another command for that. Then which means we are talking about this, the sealing value. But the floor value is 1. So now we are flooring this, so we will get actually 1. And you see that if I divide 7 by 3, we will get 2.33. But if we do floor division of 7 by 3, then what is the answer we are going to get? We are going to get 2, right? So that's the answer which we're going to get, and that is what is floor division, right? Now let's look at power operator. So we have this x and then we have this y. Now the power operator is as simple as if I say x to the x and star star y, then this simply means x to the power of y. That's all it means, right? So if I say x star star y, which means x is raised to the power of y, which will actually give me a large value, right? Which will be 20 to the power of 10. And yeah, so it is giving me this large value, which is 20 to the power 10. Let's try with for the small values. So let's say I want to raise 5 to the power of 2. We should get 25. And that's what we are getting. Let's say if I want to raise it to the power of 3, I can say star star, and then it gives me 125, right? So this is basically exponential operator, right? Now let's look at the remainder operator, right? Which we call it modulus operator. So so let's say we are dividing 5 by 2, and we get this value of 2.5, but we are interested in actually the remainder because it's not completely dividing this number. So we are interested in the remainder. If we're just interested in the remainder, then we will use the modulus operator, which is the remainder operator. And in this case, we are going to, so what is the remainder when you divide 5 by 2? The remainder is 1. So this is what you're going to get. So this is what you will get, which is 1. Okay. So great. I think these are different operators, which are called arithmetic operators, but there are more operators. And the next category of operators is, we call it relational operator, also called comparison operators. Okay. So now what are these? These are your, less than, greater than, then less than equal to, greater than equal to. These are the different operators which we have, and this is what we can use. So if I say x is 20 and y is 10, then I can use the comparison operator, right? So this is how we can use. So let's say if I'm saying x is greater than y, so what do you think? Is x greater than y? The value of x is 20 and then the value of y is 10. So indeed, x is greater than y. So the answer to this should be true. Yeah, it should be yes or true. And actually, indeed, Python will give us true because x is greater than y. And we can use the another operator, which is we are checking, is x less than y? And we are asking this question to Python, is x less than y? So in this case, because the value of x is 20 and y value is 10, Python will say, no, this is false. X is actually not greater than y in this case, right? So this is how you can use the comparison operator. And the value which we are getting, actually, we are getting is the Boolean values. We are getting the Boolean values. So Boolean is one of the data types. Now in Python, we have few primary data types, which are the basic data types, right? So what are these data types? So we have this integer, then we have float, then we have string. String is the series of alphabets, right? Series of alphabets. These are strings, like the names, right? Like Bangalore or India, United States. These are different strings, right? So these will be represented in form of strings. Then there could be messages, email messages, text messages. So all these things will be strings. And then you have this Boolean data type, right? So Boolean data types, there are only two Boolean data types, which is true and false. These are the ones which are defined in Python. So integer data type, when I say data type, what is the type of the value, right? For example, if I say 20, you know that, no? This is actually integer, and we can check the type of 20, that what exactly is the data type, and it will tell us, yeah, it's class int, right? It's of type int. Similarly, you can check for 20.5 and we'll say float. Now to represent strings, I can say John, right? So this is the string, and this is what we have, right? So now you can see that the string is enclosed inside the quotes. In this case, I'm using double quotes, but you can also use single quotes as well. There is absolutely no difference in two strings. So I can say name2 is equal to single quote John. And actually both the strings are same. I can say name is equal, we're checking the comparison, we're checking for the equality. So that's why I'm using two equal to signs. You see, it's telling me, yeah, it is indeed true that these two strings are same. And you see that this string I've created using double quotes, and this string I've used single quotes. And then even then, both the strings are actually the same, right? So this is how, these are the different data types. Now coming to Boolean, as I said, there are just two values, and these values are useful, when you're trying to evaluate any condition, right? Or in fact, you can evaluate, for example, you're writing a program for whether a number is a even number or odd number. You can always assign that the result. You can start with it as you can say 3 is actually a odd number. So in that case, you can assign even the value true or false to a variable as well. Like for example, I can say flag or value is equal to true. I can say something like this as well, right? So now I can check the type of this value, and you see that the type of this value is Boolean. And when I say, this is indeed the value which the value is stored is actually true, right? So similarly, you see that we have used X and we have used Y. Now you want to check the type of X. You can see that the type of X is int, type of Y is also int, right? So these are all integers. Okay. We can create another variable and we can say 3.5, and you can check the type. So type will give us the data type. And what is the data type of Z? So we are getting the data type is float, right? Let's check the data type for name. So the data type for name will come as string. So, right. So this is what we get. So we are getting string. So these are different data types. And so we have covered operators, we have covered different data types, and now we have also covered the comparison operators. So now let's use these comparison operators in our if and else condition. So we have been using, so this is one of the comparison operator, and you've seen that now we've used the second one also, which is less than. You can also use less than or equal to. So in this case, let's say we are saying input enter a number. So we are asking user to enter the number, and then we'll convert it into int, right? So we convert it into int, and now when we run this, now we don't know what is actually the value of the number. So we are saying if X is less than equal to 5, then if X is greater than equal to 5, then it's a big number. Otherwise, it's a small number. So let's run this. So enter. So I'm going to enter, let's say 10. Let's say, okay, X is a big number, and it indeed does that. And then it does the decrement for that. And then we are saying enter a number, and we give it as 3. Again, it says X is small number because X is less than 5. Now, what will happen if we give 5? Because we are checking for if X is greater or equal to 5. So in this case, it is going to give me, it is going to print X is a big number. Okay. So this is what we get. X is a big number, and then we do the decrement of it, right? So this is how we can use if statements using comparison operator, which is relational operator. And then what happens is, now these statements at the moment, how many conditions do we have? We are using actually only one condition, and this is the value which if will look for. Now we can combine these kind of conditions, right? We can combine this kind of condition, like for example, we can say if x is greater than 10 and x is actually greater than, or we can say x modulo 2 is equal to 0. So we're checking, is x greater than 10 and whether x is a even number, right? So that's why we're dividing by 2. And if x is getting divided by 2 and we're getting remainder as 0, that means x is indeed a even number. So we can then, in this case, we can print x is large and even. Okay, x is large and even. So let's get rid of all this code and let's run this program. And you see that if I put 20, say x is large and even, right? Now let's say if I put 21, now this value is more than 10. So this condition will be true, but then this condition will actually not be true because it's really not even. So in that case, this condition will become false. And because we are using and, the combination of these two conditions will actually result in false, which in this case, it will not go inside the if block and it will not execute the statement. So let's run this and you see that it is actually not executing this statement. So it is printing nothing. We can put an else block of code and we can say print x, either x is small or odd, right? That's what it is saying. So now if I put 21, now you see that either x is small or odd, right? So this is this is about these combining two conditions. Now, what are the rules to combine these two conditions? So now what happens is, if we have condition 1 and we have condition 2, and if there is a and in between, if there's an and in between, so if this is true and this is true, if both are true, then only the combination and will result in true. If any one of them is false, then the combination and will result in false, which means if this is true or false, or this is false and this is true, or this is false and false, in all the cases, all the values will be false, right? So all the values will be false. So this is how and will work, and this is what we call it as a truth table. Okay, truth table. Okay, we can call it as a truth table. Fine. So now this is how this if statement works. Now with and in this case, and which we are using, and operator is actually, and operator is called logical operator because it is combining two logic, right? So it's combining basically two conditions. It becomes a logical operator that, okay, if both are true and you're using and, then only it will be true. So it's called a logical operator. So we have another logical operator, which is actually called or, right? Which is called or. And the way or works, if you combine it in two, so if we have condition 1 or and condition 2, so if you have or, then if between these two conditions, even if one is true, then the entire thing will be true. So which means if one is true, it doesn't matter whether the other one is false or not, right? So in that case, it will be true. So if it is true or false, and in this case, it will be true only. So if it is true or true, then of course, in this case, it will be true. If it is false or true, then in this case, it will be true. And if it is false or false, then in this case, it will be false. That's how OR works. Let's take a simple example. Let's replace it by OR. And then in this case, if I run this and I put 21 only, in this case, this statement is false, this statement is true, and this statement is false. So this actually statement will not even be evaluated because this is already true. So because overall this condition will become true because we are using OR. And in that case, it is going to get inside, it is getting inside that X is large and even. Actually, it is not even, it is in this case, it's odd. So we'll have to say X is large or even, right? So this is what it will do that. So X is large or even. So that's how OR statement will work, right? And then there is another logical operator called not operator. So not will actually reverse the condition. Not is going to just simply reverse the condition. So if we have something like that, and let's say we have and we can actually put not in front of this. And in this case, when we run this, and if we put 21, now you see that 21 is bigger than 10, this will be true. And then this will actually return false, but this false will become true because we have a not operator. So eventually the whole statement will become true and we will get this results. And in this case, yeah, we are saying that, or even, and X is actually odd. That's what we are saying, right? It's odd. So we have put 21, and in this case, okay, this will run the previous code. Let's run for 21. So you see that it is returning X is large and odd because we have reversed this. Okay, so that's how this logical operators work. Now, so we have covered blocks, we have covered if and else statements, right? And if we have multiple, if we have one more condition, then we can also use elif, right? So elif, in elif, what happens is you can supply another condition. So we can say if X is greater than 100, then we can print this as, actually it does not go inside this, X is super large. Okay, so this is what we can do. And let's get rid of all this because we want to try to understand elif. So in this case, what will happen in this case, if you're running this program, then if the, let's say X value is 20, then it will come, it will satisfy this condition, 20 is greater than 10, so this will be true, it will execute this. And the way if elif and else works is only one block of code will be executed. So if block is executing, the rest of the blocks will be ignored. Now the control will jump ahead of these blocks. It is not going to evaluate these conditions again. Okay, so in this case, there is a bug in this problem. The bug is if I run this program and if I put 20, then this code works fine, right? That X is large, and we will just get rid of this odd. X is large. X is large, and 20, and that's it. This is fine. But if we enter, let's say 200, right? In this case, we want to print X is super large. So this is the problem, right? So if it is, so we will see that, okay, X is still printing X is large because as soon as 200 is also greater than 10 and it executes this, and then it will not evaluate any one of them. So in this case, we will have to have this condition ahead of this. So we will say greater than this, and it is super large. And then this is how we will have to change the program, right? So in this case, now it is going to work fine. If let's say we put 20, so it is going to print X is large. If we press put 200, it's going to print X is super large, right? So this is what, this is how it is going to, this is how it is going to execute this program. Okay, so now this is if-elif-else, this is how it works. Now let's look at loops, right? So let's look at loop program. Now let's write it right here. Now loops, we have if you want to have a program do things again and again, then you can actually use loops. Like for example, we want to print certain thing again and again. So let's say I say while, and I want to have a statement. I have a statement. Let's say print hello, how are you? Right? How are you? So now I want this statement to run again and again. So what we'll do is we can put a while loop and we can say true, and then we can run this. So now what is happening is if I run this, so it keeps on going. So this is actually an infinite loop and we are stuck in this. It is not going to end because now what is while doing is while is a loop. So we'll interrupt. So while is a loop, and whatever statements are there in the while loop block, there could be multiple statements. It is going to execute this again and again, again and again, again and again, till this condition is true. So here we are anyway providing true. So this condition will anyway be true, right? So this condition will be true. So that's how we are getting this infinite block. Now let's take a little better example. Let's say we want to print table of a number, and we will print. So let's say my num is 7. I want to print the table of this number. So what I will do is I want to have an increment. So I will say, because I want to start from 1, and then what I will do is I will just print num into I, right? And then I'm going to change the value of I. So every time I'm printing this first the multiplication value, which in this case the value of I will be 1, num will be 7, so it's going to print 7, and then I will increment the value. I will increment the value of I by 1 because now I want to go to 2. And then I've printed the multiplication value of num with 2. Then I want to go to 3. Then I want to go to 4. I want to go to 5. That's how I want to do it, right? So now and then I want to stop once I has become greater than 10, right? So this is when I want to stop. So let's run this, and I'm so basics of Python. I and print. Okay, so it is not even going inside that because we're checking for I, and it should go. So num into I. This is, so I was saying Python. Okay, that's interesting. So I have num is equal to 7, and I have I. Okay, I is greater than 10. So while, okay, so in this case it's not even going because I is actually not greater than 10. So this statement has to be true for while to execute. While a little bit works like if statement. So if this condition is true, this while is going to run this block, and every time it completes the execution of this block of the statement, it is going to come and check again. So now I is actually less than 10 because value of I is 1. I is going to increment this, so I will become 2, 3, and it will come till 10. So as soon as it becomes 10, it's going to exit. So we are not going to get the last multiplication value, which is basically the 7 into 10. That is something which we'll not get. So yeah, so we are reaching to 63. So we can say that I is less than or equal to 10. This is till then we want to execute it. As soon as there's a value which is more than that, in that case, we don't want to execute it, right? So this is how while loop works. Now we can actually use for loop. In this case, the while loops and for loops, there are two different type of loops. So while loop is what we have looked at. So to while loop, we provide a condition. Now to for loop, we provide some kind of a list, which is collection of items, which is collection of values. Now, what is list, right? What is list? So in Python, list basically is a collection of different values. One of the quick way of creating a list is using range. So I can use range. I can supply value 10, and then I can convert it into list, right? I can convert it into list. So this range is giving me integer values from 0 to the number which I have specified, which is 10 and one less, right? So in our case, for the table of the number, we want to go till 10 and we want to actually start from 1. So this is what we want to provide. We want to provide range 1 to 11. And this is what we are getting. So when we are using for loop, it is going to go over each one of them and it's going to take value of each one of them and it's going to use it in the program. So let's see how it works. So we will say for I in range, and I'll say 1 to 11, and then I will say print I into num. That's all I want to do. And let's get rid of let's get rid of all of them, right? So we just have num, and I is assuming the value. I is taking the value provided by this range. So range is a way to generate sequence of numbers. So in this case, range is generating me sequence of numbers from 1 to 11, right? So this is what we have done. And then if I run it and you see that we are exactly getting this output, you can actually format it a little better. You can say num, and I want to say x, which is a multiplication sign. And then I want to print I, and then I want to print the equal to sign, right? And this is how I want my output to be formatted. And you see it's properly formatted in this fashion, right? So these are the two different loops, while loop and for loop, and this is how you can use. Now let's build our project for today, which is number guessing game. Okay, so how does this game work? Now this game is basically there'll be a secret number which will be there inside the computer's mind. That's how you can think. It's inside the computer's mind, and you have to guess that number. You have to guess that number. What exactly is this number? And computer is going to provide you hint. It's going to provide you hint that is going to provide you hint whether this number, what you have guessed, is lower or higher. Is it lower than the secret number or is it higher than the secret number, right? So now in this case, the user may guess it fast or he may guess it slow. So it truly depends. We don't know how many times this loop has to be executed, right? So in this case, we will be using while loop. So while loop will go till a condition is true or false. For loop is going to execute for the counted number of things. So that's where for loop is used. For loop is used for counted number of things like list or iterable, and while loop is used when you don't have counted number of things. So in this case, we don't have counted number of things, right? So let's start afresh. Let's say, so first of all, we have to generate a sequence, a secret number. So we will use an inbuilt module provided by Python, which is called random, and that will, allow me to create a secret number. So we'll say random dot rand int, and we want to provide the range. I want to get the number between 1 to 9. So the way rand int works is it will provide you the number from 1 to 9, 1 and 9 inclusive. You can always check help and check the syntax. So I can say random, and then I can say I need help on random dot rand int. And it will tell me, okay, so you provide this A and B, returns random integer in range A to B, including both endpoints. It can include both endpoints. So I have this random, and if I just simply say rand int, I say 1 to 9, you see that it is providing me some random numbers. If I keep on running this, it's providing me some random numbers. Okay, so this is what we are going to do. So it will generate a random number. Even I will not know what is, even the programmer will not know what is a random number, right? So now we want to check. So we want to run unlimited times till the user has guessed it correctly. And we also want to check the attempts, right? We want to check the attempts. So to start with, the attempt will be 0, right? And then we will say input, enter your guess, right? So this is how we will do. And then we will store it in a variable so that we can compare it. And since it's an integer, we'll just convert it into integer so that we are able to compare with the secret number. So now, as soon as we have taken this guess, we have to increment this attempt by 1 because I have made a guess. The user has made a guess. So this is the program which you created, and you will let your friends play with this program. Okay. So now what I will do, I will check is if guess is less than secret. So I will say that no, I'll simply print your guess is lower. Try again, right? And we will check elif, and we'll say guess is more than secret. Then we'll say the guess is more than secret. Then we'll say your guess is higher. Try again. And if no else, if the so there's the third condition. Actually, it is the correct guess. So we'll say voila, you got it, right? So you got it, and then we want to print, or let's put it in the same, you got it. In whatever attempts are there. So we want to say in attempts. This should be attempts. Just so as a best practice, you should name your variables properly, right? So you should name your variables. Properly. Your program should be clean and meaningful, right? If your variables are meaningful, then your program will be much more understandable and clear. Like we have secret and then we have attempts. Anybody who's reading the program should be able to understand it. So let's see if this seems to be right. But in programming, you have to always test, right? So let's test it. So let's run, and let's say, so now there's a secret number between 1 to 9. So let's say, let me start the guess with 7, right? So my guess is higher. Okay, so let me try the guess as 4. Oh, so I got it. I got this number, and this is indeed, I got it. So this was the guess, right? And actually, just to test it out, you can also print, right? You can print that, okay, what is the secret number? Just for debugging purpose. Debugging is basically a process of ensuring that there are no issues, right? Just for making sure that your program is correct. And debugging is a process in which if there is a problem, then you try to find the root cause of the problem. That is a process which is called debugging. Okay, so now one more thing which we want to do is, as soon as this is true, we want to exit out of the loop. And the way we can do it is using break statement. Okay, as soon as the program encounters the break statement, and break is possible only inside the loop, thus this code is going to break, and then the statement is going to come to the next line. Whatever the next line is there is going to come. So break is actually not a error situation. It is a statement which we are providing to the loop, and we want our loop to break and go to, so then we can say thanks for playing the game. Okay, so this is playing our number guessing game, right? So this is what we want this to be printed once the game is over, right? So now let's try it. So see, the secret is 5. Let's not put 5. Let's try with, let's say, 7. Right? So your guess is higher. Let's try with 3. Your guess is lower. So let's try with 4. Your guess is still lower, right? So let's try with 5 this time. And you see that now, voila, you got it, right? So 4 attempts in 4 attempts. And thanks for playing our game. So this is how you can make your own game. right? So I hope you know found this session useful, and you should actually go and create your own game, and you can actually call your friends to play this game, and maybe you can increase this number to maybe 999, right? You can increase this number and see who gets it faster to make it a little bit more challenging, right? So yeah, so this is all for today's session, and then I will see you in the live session. Till then, continue to learn Python. Bye bye, take care.